To get us started, we're going to discuss really quickly the Clean Water Act. So the Clean Water Act, when it was passed in 1972, which was an amendment to the Federal Water Pollution Control Act, so the Clean Water Act really is part of the Federal Water Pollution Control Act. The old logic was that dilution is the solution to pollution. So that was the old adage prior to 1972 that was commonly used, and you'll still hear it periodically. And dilution is the solution for a lot of pollutants when they're not too numerous. So this concept, though, is really problematic with organic chemicals. So you know that you don't want to throw water on a gas fire or throw water on a grease fire in a kitchen. Why? Because water will just move the stuff around. So certain pollutants that are organic, like PCBs, if we were to draw the PCB out, what would the PCB look like? So 1, 2, 3, 4, 5, 6. Here's a carbon ring. Boom, here's another one. This is a polychlorinated biphenyl. These are phenyl groups here, and they're connected. You have all these chlorines that are also mixed in with them. PCBs have a lot of carbons, okay? A lot of carbon. There are other compounds, ketone, and then periodically even mercury. Although it's not organic, mercury gets methylated and it becomes an organic compound. And you should know from toxicology, in terms of trying to get rid of organic compounds from the body tries to add water to them to help excrete them. Doesn't work well. Organic compounds, when you get more water to it, it doesn't make it go away. It almost takes some sort of biological soap or something. In the case of PCBs, they don't go away very easily. So there's a lot more problems with organic waste, especially with groundwater when it gets in the wells, or PCBs get trapped in the sediments. They also can bioaccumulate. They get stuck in the fatty tissues of the small fish, and they get eaten by the larger fish, and then those may get eaten by the birds or other predators. So PCBs tend to bioaccumulate in the tops of food chains. For that reason, dilution is definitely not the solution to pollution when you're dealing with organic compounds. And because of that, companies like GE, and General Electric is not the only company that's dealing with these. Companies that were doing business in the 1950s and 60s and even earlier, they dumped a lot of this stuff into the waste stream, possibly not knowing their effects. PCBs, they were what were used in electrical transformers to convert the electric, to step it down from the big power plants to where it could go into the home, to where if they didn't step it down, if you got shocked, you would be electrocuted, you would die. So the transformers make the electric come into the home at a much safer level that makes it easier on our electronics, as well as decreases the risk in the event that you do get exposed. You don't test this, but if you were testing it without transformers, the outcomes would be a lot more fatal. So anyways, PCBs and other organic compounds especially do not dilute well. So dilution is not a solution to pollution, but dilution does work okay in some cases. Dilution sometimes works when you are diluting out potentially E. coli as our fecal indicator bacteria or other pollutants that may actually dilute better. So we're going to discuss though some steps beyond just dilution, biological processes that are in place in terms of how our environment assimilates pollutants.